Alfafuels is a Horizon Europe project formed by 14 partners from 8 different countries. Our aim is to develop sustainable aviation fuels from carbon dioxide. In Alfafuels project, we use the photosynthetic metabolism of cyanobacteria and microalgae to transform carbon dioxide into valuable compounds that can be used as jet fuel components. By producing fuels from carbon dioxide, we reduce our reliance on fossil fuels and we improve the carbon footprint of the aviation.
So the first starting point in the project is to develop cyanobacteria strains to produce isoprene efficiently. And by making some genetic tweaks and optimizing how we grow the cells, we aim to maximize isoprene production from carbon dioxide. Isoprene is the precursor of the jet fuel molecules, and it's a smart way to turn a greenhouse gas into a useful resource.
So next we will be focused on creating a zero-waste biorefinery process for microalgae. So after producing isoprene, we want to use every part of the cyanobacteria. This means extracting carbohydrates, lipids, proteins and other valuable compounds. We will do the same with microalgae produced in the previous tasks. It's about getting the most out of what we have.
Alfafuels will later develop new microalgae strains that produce both hydrogen and starch while growing on spent cyanobacterial biomass. We will use metabolic engineering to boost starch production and optimize growth and productivity, generating two valuable products from one sustainable resource.
Photodimerization development is about developing the light-induced process to turn isoprene into more complex compounds suitable for jet fuel. We will experiment with different methods and conditions to identify the process which is most suitable for larger scale.
The next part is focused on optimizing the isoprene photodimerization. This means fine-tuning the selected process to get the best yield and recovery of products. We will look at different reactor setups and operating conditions to make the process as efficient, cost-effective and sustainable as possible.
In a future stage, we will develop detailed models to optimize the whole process of isoprene production. These models will help us understand and improve each step, making it more efficient and economically viable. It's like creating a blueprint for success.
So finally, we will take all these technologies from pilot lab to pilot scale. This involves building pilot systems for photoconversion and photodimerization, aiming to produce aviation fuels that meet international standards. It's a big step from research to real-world application.
Alfafuels tackles systematic barriers in sustainable aviation fuels, such as high costs, inefficiency, and scalability challenges. By producing sustainable aviation fuels from carbon dioxide as the only carbon source, the project reduces feedstock costs, improves resource efficiency, and implements a scalable, zero-waste production process. And these achievements are really important milestones towards the decarbonization of aviation.